Everyone, this is Mr. Galisi, and today we're going to be learning about if statements and how they are used to make decisions in Java. In order to make these decisions, we have to evaluate a Boolean expression. Now, that Boolean expression could be something like, is x greater than 5? And if it is or isn't, we'll determine where the program takes us. It could also be something like a Boolean variable, which can be expressed as either true or false. A very simple if statement, like we see in the first example at the top here, has only one if statement with one Boolean expression inside. Now, we haven't said what that Boolean expression is, but if this Boolean expression evaluates to true, then the statement inside of that if block will be executed. If we say that the Boolean expression is false, then the statement or block inside of that if statement will be passed and go outside the if statement and continue the program from where it left off. To put that more simply, when the if statement is evaluated, if it's true, we execute the statement inside. If it's false, then we skip it entirely and go to the next set of executable lines in the program. The next example, that's a little bit lower, shows a Boolean expression that has more than one outcome. The if statement at the top here, if it is true, then we go ahead and we do the same as we did before, and we execute the statement or block that's on the inside. But once that evaluates to false, that first if statement, then instead of skipping the entire if block, we would go to the else if. Now, this is used to show multiple paths within a certain decision, like to turn right or to turn left or to go straight. It's not just a two outcome decision, it can be multiple decisions that are made. So, for example, if you receive a grade of a 90 or higher, then the statement inside here would be you receive an A. Else if the grade is an 80 or higher, then the statement or block would be run that says you receive a B. Now, the else if requires a Boolean expression, like the original if statement. The only term that does not need an expression is the else. Now, we saw this example in the Animal Picture Lab where we were choosing our own colors to import for the square, circle, all the different types of shapes that we were doing. And as a default, we saw that all of those shapes would turn black if the color that we chose was not within the if statement block. That else is a catch at the end for any other statement that does not satisfy the original if or any of the other else if statements that come after it. Now, in this example, we only have one else if statement, but we can have as many as we want, where this if statement block could be many Boolean expressions long, starting with an if, and then having multiple else if statements in the middle, and then finally at the end, an else statement in order to catch any kind of default value that we would like at the end. Now, as we look at this first example, we are trying to emulate how much money someone would make babysitting. Now, we have our method called babysitting money that takes in a parameter of the number of hours that someone would work. Now, we have our if statement on the inside that tells us if the hours are above 20. So if that integer that we're taking in as a parameter that the user puts in is above 20, then we're going to say that the number of hours times 15, being the rate that they make as, let's say, overtime, would be returned to the user. Now, returns are not something that we have talked about at length. All of our methods up to this point have been void, and those are good for print statements that don't give the value back to the program in order to use at a later time. Prints are just something that we display to the screen and are not something that we can use later in our program. So when we return a value, that is something that we can catch and use later on in our program. Now notice how after the if statement, if the number of hours worked is not larger than 20, then this inner portion would be skipped, and instead you would take your number of hours and multiply it by 9 instead. Moving on, the next method that we look at will act as a sort of an error catching if statement to redirect the user or to maybe have them try again for values that we don't want to accept within our program. So for example, if we're at an ATM and we don't have any money in our account, so if our money is less than 0, then we're going to say you cannot take out that amount of money, and then we would prompt the user to pick another number that would work and that we could dispense if it was an ATM machine. Otherwise, we would say, here's your money and here's the amount that you would have. If statements are especially useful if I am expecting the user to put in a certain type of number. And let's say they punch in a string or a word and I was expecting a number. This would allow us to stop them from giving us invalid input and then prompt them again to give us the amount that we would like. Here are some statements for you to try. And now remember, before we give this a shot, think of every if statement and its values afterwards, so every else if and else that's after it, as one question. So you're on a path and you have multiple ways to go. Would you like to turn right, turn left, or go straight? That would be one if statement, one block for one question. So keep that in mind when you're going to try to evaluate both of these methods and what they would produce given that x is equal to 9 and then x is equal to 11. So go ahead and pause the video at this point and we'll talk about the answers in just a moment. Wow, great job. You got them all right, I guess. So let's look at the first if statement block here and why we receive the result of 200 here for when x is equal to 11. So at the beginning, the x value that we're taking in from the user is 11, so that when we evaluate it in that first if statement, 11 is obviously not equal to 9, so we would skip the if statement and go down to if. 11 is also not smaller than 10, so we would skip the else if statement and get down to our catch at the bottom, our else statement, thus giving us a total of equal to 200. When we evaluate x is equal to 9 in this first statement, we would hit the first if, it would jump into the inner if statement because x would be equal to 9, our total would equal 100, and instead of going down to the else if, since the first if statement was true, we would jump outside of the entire if statement block and continue on with our program from there. Now the second and more interesting method on the right-hand side here, if x is equal to 11, that first statement is still obviously false, but notice how the first if is its own question, just like the bottom set of if-else statements is also its own question. So in the first example, we're asking just one thing and we're giving one result. Here in the second method, we're asking two different questions. Is it equal to 9? And for when it's equal to 11, when x is equal to 11, we would say, no, that's not equal to 9, so therefore our total is not 100. But then it's asking another question. Well, okay, then is it less than 10? Which is also no, but instead of jumping out completely, we would go to our else statement, which would then assign total equal to 200. So where things get really interesting is when x is equal to 9. That first if statement would evaluate to true, thus giving total equal to 100. But then we go to the next if statement, a completely separate question from that first if statement. So Total would have been equal to 100 because x was equal to 9, but then x is also less than 10, thus overriding the total value of 100 to now equal 50. So at the end, total would be equal to 50 by the time this entire method is completed. A lot of students have trouble with this thought that each if block is its own question. If I were to put just if statements, multiple if, like if this, if this, if this, if this, those are 4 or 5 different questions that we're asking, and they would not be skipped in the execution of our method. Here are some other operators we can use to evaluate Boolean expressions. Now, in order to say equal to, we would use 2 equal signs to say, is this value equal to another? Is x equal to 10? So that would be a question. 2 equals is evaluating the expression, where a single equals was assigning a value to a variable. So x equals 10 gives the value of 10 to x, where x double equals 10 is asking, is this value equal to 10? Instead of using 2 equal signs, if I put an exclamation point out in front of one of the equals, I'm saying not equal to. Now, we can also use the not for turning expressions from true to false. So what I mean is, if I have if x is equal to 10, if I were to put the not in front of that expression, I would say if this evaluates to false. Now, we'll get into that a little bit more later, but I can negate full statements and not just negate an equal sign, so not equal to. Now, there's the normal greater than or equal to, less than or equal to. But at the bottom here, we have conditional operators that allow us to have multiple expressions in one if statement. Now, the first, with our 2 ampersands here, would give us the and statement. So this and that. The condition would only be true if both expressions were true. The second, the or statement, would evaluate to true when only one of them or one of the expressions is true. So this or that. For example, you could eat cake or ice cream at your birthday party. That means you'd be happy having either one, this or that. If you wanted to have cake and ice cream, you're only going to be happy when you get both of those values, or I'm sorry, both of those desserts to eat at your birthday party. Let's put that into an example. Your parents tell you that you can have dessert once you've done both of your chores. If you've done one of the chores, then you can have a piece of candy. So here's our void statement with 2 Boolean values being accepted as parameters. Now, we would set these values when we ask the user. So we would say, was the room cleaned? And you would say either yes or no, true or false, and then have you walked your dog? And so when we look at the if statement, cleaned room is already a true or false value because the user told us whether or not they already cleaned a room or they walked their dog. So if they said yes, they've cleaned their room, and in addition, they've walked their dog, then they can have dessert. Yay! Else if this first statement does not evaluate to true, we go to our else if statement where they either clean their room or they've walked their dog, meaning they've done one or the other. Now, obviously, if both of them were true, then this whole statement would be true, but we only need one with an or statement to express the Boolean expression as true. So then they have a piece of candy. Our catch at the end, our else statement, would be that they didn't clean their room and they also didn't walk their dog, meaning they have to get out of my face because they have to go do their chores, and then they can get some of their candy that they want. Next, we see an example of an AP-style multiple choice question where you'll see this type a lot where they'll have answer choices that are 1 and 2, all of the above, none none of the above. So it's useful to try your best to eliminate answers as you go. But again, here's another chance for you to pause the video, try the question on your own, and then we'll go over it together in just a moment. Wow, you did it again! 2 for 2! So the answer is A in this case. So when we look at accumulating bonus points on the test, you'd have to get all 3 of the bonus questions correct in order to get the points. So when we look at the first value here, is if you get the first one and the second one and the third one, we're going to add the extra points of 5 to your grade. Now this is the first time that we're seeing plus equals. Plus equals just stands for grade equal to grade plus 5. Now this is shorthand that we'll talk about a little bit more later, but for right now just know that we're adding 5 more to the grade. So in this case this would work because we're only letting them get points when all 3 of these Boolean values are true. When we look at the second one, the ors in here make it true where I only need 1 of the bonus values in order for the statement to prove true. So I get 1 of the bonus questions right, I get the other 2 wrong. This would still evaluate to true, and then I would get my bonus points, which is not what the question is asking. So 2 is the wrong answer and is out. So that would eliminate B and eliminate E. If I'm looking at example 3, I have 3 if statements, so 3 separate questions. So if the first bonus is true, I get 5 points. Then I go to the next if statement. If the second bonus is true, I get 5 more points, so I have 10 now. If the bonus is true again, I get another additional 5 points. So that'll be 15 in total, which is not what the question was trying to emulate. So 3 is, again, not one that we would use and would not be a good answer to prove that all 3 bonus points get you 5 extra credit points. Real quick, here's another AP style example for you to try. Again, pause the video and we'll be back in just a second. So the answer here is answer number 2, where when we look at the table here, we see that when a number is divisible by 3, we multiply its result by 10. So that would be true for 6. When it's also a multiple of 4, we would multiply it by 10. But when it's not a multiple of 3 or a multiple of 4, then we don't multiply it by 10 and just give the value for n. So which one of these statements shows that kind of pattern? And in the first one, we have if it's divisible by 3 and divisible by 4, then we return 10. But I don't want when they're divisible by both, because when we look at the example of n equals 3, then that's not divisible by 4, so that would not give us a result of 10. So this first one would be out. But for example 2, if it's divisible by 3 or divisible by 4, which is what we're seeing here as a pattern in the table, then that's what I would return to the user as times 10. Notice how the return n over here doesn't have an else statement to it. If the if statement up here is false, it would skip it and then return just n without being multiplied. That's what it's showing. Now example 3, you'll notice has an if statement tucked inside of another one. We have an if here and then another if inside. That's called a nested if statement, which just means that if the first statement is true, then we're going to go inside of that if block, but we're going to be asked another question immediately. If it's also divisible by 4, then we return it by 10. So really, in essence, nested if statements act like and statements. If this part is true, then I go inside, and then if this is also true, then I would return times 10 and show that the result is 10 times whatever n's value is. Lastly, we're going to look at short circuit evaluation for ands and or statements. Now, all short circuit evaluation means that if we know that the term inside of our if statement is already going to have an end result of true or false, then it doesn't even bother evaluating the second half or the second Boolean expression in our if statement. So for example, if we look at the if statement that we have here, if n is not equal to 0, and we have this expression here, notice how n is in the denominator. If it were equal to 0, then that fraction would throw us an error because we can't divide by 0. That's an arithmetic exception. So we would want this first statement to, if it proves to be false, I want it to jump out and not execute this second Boolean expression to give us an answer. So in an AND statement, when we already know that the first half of the statement is false, then I know that the whole statement is false, because both terms have to be true in order for an AND statement to prove true. So in an AND statement, if the first section is false, then we jump out and don't even bother evaluating the rest of the expressions. Now, for an OR statement, when the first value is true, I only need one for an OR statement. I only need one expression, I'm sorry, to be true for the whole OR statement to be true. So if this first value is a true Boolean expression, then I would skip the second because I already know the final outcome. I already know that the entire OR statement would then be true. So that would just be an example of short-circuiting, where it sounds like a scary term, but it just means that we're only going to evaluate as much as we need to and not bother with the rest if we already know the final outcome. Here's just a final example of short-circuit evaluation where the Boolean value that is given to the user or given by the user, if that were to be false, then this first statement would never evaluate x is less than 10 because it would already know that the whole thing is false. And if has power is true, then the OR statement here would already be true for the entire thing because one of the statements or one half of the expressions were already true, which would allow that to jump out. All right, that is if statements and conditional statements. You have a Google form to fill out that is attached to this assignment, and I look forward to seeing the comments and questions that you have.